Alright, so for this quick video outline, I just want to go over four main things, the equations that we need to know for this quiz or test. The first being speed. We know that speed equals distance over time. The distance is usually in meters, the time's always in seconds, and your speed will be in meters per second, which I'll get to in a second. Secondly, we have distance formula when we're solving for speed. So we have distance equals speed times time. The last one in a set of speed equations is time. So for solving for time, we know that distance over speed equals time. The units involved with speed are as follows. We know we have speed, we know we have distance, and we know we have time. The speed is always going to be in meters per second. We know that acceleration has meters per second squared, but this is meters per second. We have time. Time is always going to be in seconds. Always have to convert that if it's not. And the last one would be distance. And the distance here, or on the test I should say, is only going to be in meters. Conversions, some of you have mentioned that you don't really get the conversions. We know if we're going metric to metric, all I have to use is our chart, King Henry chart. But if we're converting from minutes to hours, the easiest thing to do is just multiply your minutes by 60. The fourth equation we do is momentum. Okay, momentum is very simple. Here it's easy because you won't have to weigh anything like we did in the lab. But to find the mass will be given, and it's going to be in kilograms. We know that P is representing momentum, and velocity we know is in meters per second. So for solving for momentum, we need the units also. When we see this problem asking for how much momentum did the vehicle have, we know that the mass is in kilograms. We know that our velocity is going to be meters squared. And then once we solve for P, which is once again momentum, we know that it's going to be in kilograms times meters per second. Might get a little tricky, but if you know your mass is in kilograms and your velocity is in meters per second, it should be a no-brainer. So once again, kilograms equals, or it's kilograms times meters per second. Alright, so now the lights are in the board here, but so be it. You know that says acceleration. Acceleration we've done now many times. Alright, this is also three equations. Okay, acceleration we know, and we've done it. It's acceleration equals velocity final minus velocity initial over time. Alright, VF minus VI over T, or V2 minus V1 over T. Okay, always know that's the final velocity minus the initial. That gets you your change in velocity. Okay, so if we're solving for time, it's basically the same thing, except our time and acceleration are flipped, and we solve for T. And last we have our solving for V2, which we had on the worksheet. We know that V2 equals V1 plus acceleration times time. Okay, that's if you're solving for V1, same thing is flipped, VF, VI, whatever you want to call it. You can memorize these equations, or you can just use the algebra like a lot of you like to do. If you feel more comfortable memorizing these, here they are. Alright, our units for acceleration are meters per second squared is for acceleration. We know that because we have the seconds in seconds divided by our meters over So our units for acceleration are, acceleration is meters per second squared. Our time is in seconds. If we have to solve for distance, which we're not going to, but you know it's going to be in meters. And we have velocity is in meters per second. Alright, so the last thing I want to discuss is displacement. We talked about displacement today, and we talked about it a lot throughout the semester. Displacement, basically, just to sum it up for you guys, is we have our starting point, let's say the end zone. We'll use this as our end zone. We go out to the 50-yard line. Alright, we'll use meters here. We go 50 meters up and then 25 meters back. Alright, it's not total distance, it's displacement, so we're closer to our starting point, which is the end zone. So we've displaced 25 meters, alright? So displacement here is 50 minus 25, which just gives us 25, but the distance is the total amount we traveled. So we want out 50, then back 25, giving us, what, 75 meters, alright? That's all you got to know, and you should be fine for tomorrow. And that is all. Good luck.